Welcome to integration by parts involving natural log of x. So recall, we have the derivative of natural log of x is 1 over x. And we also have the integral of natural log of x dx is x times the natural log of x minus x plus c. So we can now treat natural log as a component to be used in regular integration by parts. So for example, let's go ahead and evaluate the definite integral from 1 to 5 of x cubed natural log x dx. So note here that the integral of x cubed is much less complicated than the integral of natural log. Again, note the integral of x cubed dx is much less complicated than the integral of the natural log of x dx. Furthermore, the derivative of natural log of x and or is not really any more complicated than the derivative of x cubed. As a result, it would make sense to pick natural log for our u and pick the x cubed as our dv component. So, I should have noted that first up, we are finding an antiderivative since we're doing a definite integral. We are going to try integration by parts. Since the derivative of natural log is easier to work with than having to throw in an integral of natural log, we will go ahead and pick u to be the natural log of x. And we will pick our dv to be x cubed dx. So if we make our table, we have natural log of x for u, x cubed, technically dx, for our dv. We differentiate down the left, integrate down the right. Differentiating natural log x, we get 1 over x. Differentiating x cubed, we wind up with 1/4 x to the 4th. Now notice if we multiply these, we get a rather simple product. So we are just going to stop here. We'll do our plus the product of the diagonal minus the integral of that product of the bottom row. So the reason we're stopping here the bottom row gives a simple product. So we stop here. Right. So we have the integral of x cubed times the natural log of x dx is equal to the natural log of x times 1/4 x to the 4th minus the integral of 1 over x times 1/4 x to the 4th dx. So of course we are looking at 1/4 times the natural log of x. Sorry, 1/4 x to the 4th times the natural log of x. Minus 1/4 times the integral of x cubed dx. The integral of x cubed is 1/4 x to the 4th. So we wind up with 1/4 x to the 4th times the natural log of x minus 1/16 x to the 4th, and then plus c. So we found our indefinite integral, we found our antiderivatives. Sorry about that. Scrolling back down. Next up, we find the definite integral. We were asked to find the definite integral from 1 to 5 of x cubed natural log of x dx. So we are looking at the definite integral from 1 to 5 of x cubed natural log of x dx. We know our antiderivative of 1/4 x to the 4th natural log of x minus 1/16 x to the 4th. And we will evaluate that at 1 and 5. Plugging in 5, we get 1/4 times 5 to the 4th times the natural log of 5 minus 1/16 times 5 to the 4th. Then we subtract off 1/4 times 1 to the 4th times the natural log of 1 minus 1/16 times 1 to the 4th. Natural log of 1 is just 0. Sorry. So this simplifies to 5 to the 4th is 625. So we have 625 fourths times the natural log of 5 minus 625 sixteenths plus 1/16, or 625 fourths natural log of 5 minus 624 sixteenths. We could, of course, simplify that if we wished. And if we simplify this, we wind up getting 625 fourths times the natural log of 5 minus 39. So this is our definite integral, or an integral involving powers of x times a natural log. This is a trick we can use. Again, natural log gets way too complicated when we integrate to use for our dv, so we chose it as our u instead.